Okay, geographers, phase 2 of our precipitation work here. So I've gone through, I've fixed all of the cities and different place points so that we can do the proper joining, right? And this is stuff that we went over way back in the intro to GIS class. Joins and relates are pretty standard, kind of basic things and very useful, as we'll see here. Oh, I'll also point out I did not, I didn't waste my time going through and doing the 2023 data entry because, I'm a big shot. I don't have to do stuff like that. So I left that blank. But again, I want you to do, you're going to be mapping out 4 years here, 2020, 21, 22, and 23. So make sure you update that stuff. I haven't done it. And in fact, make sure this is a point where if you haven't already done it, go ahead and do it because it'll make life easier for you to go ahead and finish this before you move on. Okay? So just saying that. So pause this, do the data entry, then come back. Okay. So I've got my points as I want them. And so I want to do a join. And with the joining, it's a case where we're always right-clicking on the actual feature class. Okay, not the table itself, but the feature class. Right-click here, joins and relates, add a join. Okay, so our input table is this SoCal weather cities to start with. In fact, where I don't have it. There's no. Okay, whatever. I was thinking it would have help things so you can kind of go through if you can't remember this stuff. But c'est la vie. Now we've got this red X thing here. What it's trying to do is trying to think for you. It's saying, look, you want to join these two things. You got one standalone table. You got this feature class. You probably want location and location to match up. No, that doesn't exist over here. So we want to make sure we select name on this side. Now it's a warning. It was not in the index thing. Don't worry about it. Not a big deal. See, join table. That's good. Join field location. That should be good. Let's go ahead and hit OK. And this is what I love about joining. If it works, it just works. Have a little faith. What you can do is click on any of these. Santa Barbara here. And yeah, if it works, what you'll see is attached to this city's attribute table information, these different fields. We've got location, and we've got precip 2019, 2020, and so on, and they have values in there, right? You might have, if it doesn't work out, if you didn't put stuff in the right order, didn't completely match what I just had on the screen, it might say null the whole way down. Where it gets the sense of what you're trying to do, but it doesn't quite work. So you always want to check this. Just click any of these values and make sure these features and make sure that the values are there that you're looking for. Okay, and again, this null is simply because I haven't done anything for 2023, but I should see this stuff for 2021 and all these other years. Okay, so now we have just linked our precipitation data to the actual location on the map. Okay, that's huge for us. I'm going to go ahead and close. I'm going to close both of these because I don't need those. I'm going to hit save just because I did something. And I'm going to now turn off, in fact, not even turn off, remove this topographic map and hill shade just to get rid of that preloaded amateur stuff right there. This is all I need. I'll leave these harsh red things right here. But now I'm ready to do a little spatial analysis to do some real work. We're going to do what's called interpolation, which what it means is a fancy way of saying filling in the white space. Okay, so we have values. I can click on any of these and I can figure out exactly what the rainfall totals were for the year 2021. Okay, any location right here. It's kind of useful, kind of interesting, but what we're going to do is we're going to make this even better. We're going to figure out what the precipitation was in this area, and like this area here and over here. Anywhere there's this white space, we're going to create precipitation data. And it's not just going to be guessing, it's based off of the values that we already have, right? And there are a few different ways. We'll get into the different, two of the different ways we can do some interpolation in here. One is better for what we're doing than the other option, but it's worth knowing both of these kind of basic ones. Okay, but it's a case where we're going to create a complete and continuous precipitation map for this whole county area. Okay, before we do that though, let's go into analysis and go into environments to make sure that when we're doing this interpolation, when we're messing around with creating new rasters and all that, it's just doing the work where we want it to. Okay, it's kind of like what we did with that hurricane stuff last time. Same idea. We want to fix everything within these county boundaries, mainly because it's just going to look cooler. Okay, it's a case where technically you could, do some interpolation out here, and it could come into the oceans and all of that. But really, it looks kind of amateurish when you've got just these big rectangular rasters that kind of don't fit with the location. So that's the goal. So with this output coordinates, like we did before, we can select one of these, make sure all our stuff is staying in this teal Albers projection. Extent, go ahead and do extent of a layer and select counties. Okay. And then and that's, well, we'll be fine with that. That's because our map, I think, is being drawn in the WGS step, but the data at least are as they should be. Raster analysis mask, because we have to navigate to it. But do this SoCal counties. Hit OK, and then everything else should be good. So we'll hit OK. All right, and again, hit save because I did some stuff. Now, I'm going to go to Tools, still in Analysis, Tools, and I'm going to search for, I'm going to put IDW. Okay, so IDW, inverse distance weighted, is our first type of interpolation. And it's based off of Tobler's first law of geography, which I'm not a huge fan of. But it's the idea that things that are closer together are more alike than things that are further apart. Okay? So like in the case of precipitation, it's the idea that, if you're going to have rainfall, if this area got 12 inches of precipitation for the year, immediately surrounding areas most likely are going to have 12 or something pretty close to that for their precipitation counts, right? Whereas if you go farther away, not necessarily going to be, 12 inches. Especially if you think about out here in, Southern California, we've got coastal locations, we've got deserts, we've got mountains running all around here, things we can't necessarily see, but there are going to be reasons why, say, Lancaster's precipitation is going to be closer to Palmdale's precipitation totals than, say, what we've got in, Oxnard, right? Or Santa Barbara or whatever. Okay, that's the idea. And the reason why I say I don't like Tobler's law is it works for rainfall or elevation or things like that. When it comes to human society, I mean, like right now, right? This is, I'm recording this in my office. It's being, beamed to wherever these YouTube servers are. It's getting, downloaded into your, bedroom or office or on campus or, computer lab, whatever it might be. It's the idea that where we're located can sometimes not matter. right? And you know that made me feel dirty. Like it always matters, but the idea that this idea of things that are closer together are always similar, not necessarily the case when we get into humanity and society and that stuff. Okay, that's just me ranting. But anyway, when it comes to doing some precipitation or something like that, it works. And this is what we call a deterministic type of interpolation, in that it's pulling directly from these known values. Okay, so let's go ahead. And you can, oh, see here, I think I mentioned this last time. We've got 3 different tools here where it all says IDW, but in parentheses, 3D analyst, geostatistical analyst, and spatial analyst right there. It's the same tool. So you can click on any of these. You should, I think, if you did a full install of ArcGIS, you should have access to all of these. I'll just click on the spatial analyst because that's my favorite one, but it's the same tool. It's just different ways you can access it. It's the same. Okay. So here, input point features, and here we actually have the help stuff right here. So as you're doing any of this stuff, if you're not entirely sure in terms of what you should be looking at, or what you should be putting in here, whatever, always check that help. But the drop down, pretty straightforward. We only have 1 point feature class in here. We want that. SoCal weather cities. Z value. This is what we're actually mapping. All right. So it just gave us this first one it found. Population from the year 2000. No thanks. We don't want any of that. We want one of our precipitation values. So I'll do 2020 to start with. Okay. Output raster. It's going to give you this, generic thing right here. It should be saving to our, SoCal precip thing. But I'm going to call this, I'll just call it IDW 2020. Okay, that will remind me that this was using that inverse distance weighted tool, right? And it's for the year 2020. So it makes sense to me. All this stuff I'm going to leave as is. These defaults work. The general rule is, like, if you don't know what these defaults are, just leave them alone. The computer will know. You should change them if you do know that, actually for what I'm doing, I should change this stuff. And you would know to change this stuff because before you embark on something like this, if it's not for some class assignment or an instructor is telling you what to do a little research, right, on things. Do some Googling on interpolation, precipitation, ArcGIS. Throw those different keywords in there and see what pops up. Either forums, some kind of Reddit post, whatever it might be, where somebody's talking about it. Maybe there's an academic article that pops up with a lot of detail in here. Just kind of look through, get a sense of what other people have done and why they've done it, and then you start to learn how this stuff works. That said, we're going to leave this as is right here. Okay, that looks good. I'm going to hit run, say a little prayer to the GIS gods that it will work. It's thinking. Oh, magnifique. Look at that. We have data, right? And right now, it's using this hypsometric tinting, this classic elevation color scheme right here. If I go here, to our symbology thing, either go to the tab or right click and go to symbology. It should bring you here. You can change it to something that would make sense, right? Some kind of blue color. Just select that. Now, one thing, when we look at it, you might look at that like that's blue, but it's going darker means less, lighter means more. Sometimes that works. Sometimes that can be confusing. We tend to go with darker means more. Okay, and when it comes to precipitation, I think that's a good move. Now we can trying to remember. I can never remember. Here we go. Reverse values, right? Wait, oh no, that just reverse it there. What? It used to be so easy. You would just like right click right here. And it would just, you could flip it. I think. Where's the ding? Wait, reverse symbol order? There we go. Okay, it was reverse symbol order. That's what we want to do. This is what happens when you are old. You're gonna learn this. You're gonna think like, oh, look at Grandpa here, can't figure out his computer, and you're mocking me right now. I'm sure I can feel it. But you're gonna get there, right? In the year 2038, when you're an expert in this stuff and you're teaching other people, and you're using ArcGIS, awesome version 8.6, and it's totally different from what you learned on. You're gonna do the same thing where you're just like, I don't know. So get ready for that. But yeah, there we figured it out. So you can pick a color that works in here, some color scheme that works. And yeah, I think that looks better. Darker means more, lighter means less. Okay? So that's it. That was pretty simple, pretty straightforward. Just had to click that tool and enter a little bit of information. And that's pretty amazing what we have. And this is the cool thing with this stuff, is that we can trust it. Like this is a scientifically valid method of interpolating data, creating the data, filling in the gaps right here. So we can trust this, right? And it might be a case where if we come in to one of these areas, let's zoom in right here. Okay, it might be a case where, in this zone, there is slightly more or slightly less precipitation. These little boundary lines that we have might not be completely true to reality, but for a, kind of big regional analysis of this location, getting a sense of where was rain falling, where wasn't rain falling, this is fantastic. This is perfect, right? So we can get a sense that in the year 2020, what was going on here. All right, so here, let's hit save. And what I also want to do is I'm going to rename, so right click and go to properties here. And I'm going to put 2020 in here. Okay, because we're going to do 2021, 2022, and 2023. So I'll do that to help keep it straight in my head. Okay, so got that. Hit save again. Okay, now we learn how to do that. IDW, awesome. Here's the problem. IDW, we don't want to do that. It's not as good for precipitation. All right, it's actually what we want to use is what's called kriging. And it's K-R-I-G. So kriging. We have two options here, 3D analyst, spatial analyst, same tool. But kriging is another form of interpolation, and it's better for precipitation because it is. Because I read this, because people have studied this stuff. And it goes back to the idea of Googling and doing some research and looking at it, what other people have done. And with kriging, this is very useful when we have something with directional bias, meaning that there's some kind of directional trend to the data. And when you think about precipitation, clouds moving in, rain falling, where mountain ranges are, air's getting pushed up, rain falling down over there. There's going to be some kind of directional bias to this stuff. So therefore, kriging makes more sense. And this is what's called a geostatistical model, where instead of just, that deterministic IDW, it's running some statistical analysis, looking for all sorts of spatial autocorrelation values as it's going through. I don't remember. I read about this stuff a million years ago. I could read about it again if I really needed to know the underlying what's the math that's happening. But I don't care about that. All I care about is hey, kriging is what I want to use when I'm looking at something like precipitation. Okay, so with this thing, same kind of deal. Input, it's points again. Z value field, and I do 2020, same exact thing. The output surface raster, I'm going to call this one kriging, and then 2020. So I can keep track of it. I'm going to leave all of this stuff as is. I'm going to hit run. Let's see. Okay, gorgeous. And in fact, I'll leave it as is with that color scheme. Oh, actually, no, you know what I'll do? Because I want to compare these things. So let's do this instead. Let's pick like maybe the green. Right. Well, that one's actually too subtle. Hold on. There, that'll work. So what I'll do now, if I go to raster layer and swipe, you don't have to do this, but you can do this. Raster layer swipe, I just want to compare, so I'm left clicking, holding, and dragging, compare these different surfaces. Okay, and so as I move it, it's removing the top one, the kriging that's selected over there, and showing what's underneath it. And so this is kind of cool because it'll show, it's an easy way to compare these things. So you can see it's not a perfect match, the IDW and the kriging, but at the same time, I mean, it's pretty close. You could present either one of these and it wouldn't necessarily be the end of the world for, some visual analysis, whether you used IDW or you used kriging. But just based on good practices here, what you want to do is use the kriging interpolation for 2020 as well as the other years. So in fact, let's hit save right here. So now what I want you to do, and you'll do this on your own, is insert some new maps. Okay, we're going to rename this one 2021 in here. And what I can do is actually, this is kind of nice, I can copy both of these, the weather cities and counties, come over here, right click and hit paste, and it brings that in. Okay, I'm going to go ahead and remove this stuff. Okay, and it's a case where, and looking at this, I've got two different, let's see, right click in properties, coordinate system. So this one is showing it in teal albers. That's why it looks so much better. Let's go ahead and change this. Right click, properties, layers, teal albers, hit OK. Just looks a little tighter, a little more true to life right there. Just so these will look the same. Because we're going to be making a layout at the very end of this whole thing, showing these 4 years and comparing these things. So we want them to look the same. So I got that. You can do this in any order. You can go ahead and insert a new map and right click, do all this same stuff for 2022 and then do one for 2023. All right. And I should be able to right click paste. Yeah, not have to recopy this stuff. So you can do that. You can get that set right here. In fact, I'll go ahead and do one more map. Now let's go ahead and paste that. And then right click properties. We'll call that 2023. Okay, remove these things. And this is also a case, I mean, you know, I'll just leave this as is. You can see why it can be useful too to get this completely like you want it in terms of font, color, all the symbology stuff in here because I, copied and pasted and it kept that red scheme. This works for what I'm doing here, so I'm fine with that. I'm not too hung up on it. But if I had elaborate symbology that I wanted to do, and I hadn't yet done it. If I just left this in Tahoma, all the default stuff, and I'm copying and pasting, it means I have to change it 4 different times, right? So it's kind of useful to get the stuff a little prettier over here before you start this copying and pasting. Okay? Just, FYI. So you're going to copy these things over and you're going to do this Kriging interpolation for the years 2021, 2022, and 2023. Right? So same process. Don't get hung up on the symbology stuff because we're going to talk about that in the next video. Okay? So for now, in here, just get all of these different raster surfaces. Now, for some of you, this will happen just because it seems to happen. For most of you, it's going to be fine. You're going to do Kriging, everything's going to work, it's going to be beautiful. Some of you are going to try the Kriging for one of these years, and it's just going to look weird. It's going to be angular and ugly, and it's not going to quite, it's just going to look off, right? It's not going to have this nice, rounded surface look. It's going to be very angular. I don't know why. It just seems to happen. Maybe it won't happen. Maybe it's finally fixed with some of these updates. But I've had this happen with students all the time. When we try some kind of interpolation, Kriging will flip out. If that's the case, go ahead and just use IDW for that year. Okay, so start with Kriging. If it's horrendous and ugly for that specific year, don't worry about it. Just do the IDW interpolation, and that should look good. If you do that and it doesn't look good, number one, double check that your data, you copied it. You can look at the attribute table, make sure that you've got the values that you should have in here. Nothing looks weird in there. Well, that's good. Shut it down, update your software, like all these different things I talked about previously. If that still doesn't work, if any of these years don't work, contact me. We'll try to figure that out. But just so you know, if Kriging is hideous for like 2021, go ahead and switch to the IDW. Okay? So that'll end this video. Go through before you start the next video where we get into how we present this stuff. What I want you to do is have raster surfaces for all of these years right here. Okay? Okay, have at it. Have fun. I'll see you in the next video.